you been?
Thanks, Rob. So I've been following Chris's project for quite a while. Chris is a software engineer at NVIDIA, where he provided us a great bio, so I'll read it. Chris, Golf 7 Lima Quebec X-ray, studied electronics at university, but quickly moved over to software and has worked at NVIDIA for 26 years, developing software debugging and analysis tools for game developers. These days, now his children have gone off into the world. He uses extra space and time to indulge his inner maker, focusing on electronics, radio, and computer projects. And the project he's going to talk about today is super cool. I'm really looking forward to hearing more about it.
All right, thank you.
And you're up, my friend.
You're up. We'll turn it over to you.
Good evening. I'm getting some interesting glitching here, but hopefully once I start talking, it'll go away. It seems to be related to, bizarrely, how big your video is on my screen. So everybody can hear me, yes?
Yes.
All right. So I'm not used to Zoom. I'm used to Teams. So I'm just trying to find out how I share my screen, but we'll get there.
If you put your cursor at the bottom tray, it may pop up and you'll see a green share. Oh, you got it.
I got it. I got it. So I just need to go to present mode, I guess. Let's see if that does something. Everybody can see that?
Yes.
Good, and I don't seem to have the glitch. So do let me know if you can't hear me. I don't have a headset. I'd use a conference speaker, but I've never had any complaints. So yeah, so I'm Chris Maughan, G7LQX. I'm based in the UK. I've probably got bed hair. It's 3:30 in the morning here, so this is a first for me. I don't usually have to make sense at 3 in the morning, so please do shout up if something doesn't make any sense. Yeah, so as Benjamin said, I work at NVIDIA. I've been here 26 years. I work on C++ mainly, GPUs and user interfaces. I couldn't show a screenshot of the thing I work on because it's proprietary to Nintendo, but this is something else I've done in the past. It's a graphics profiler that lets us look at the internals of our GPUs. So that's kind of what I do for the day job. I studied electronics at university at Hull. That might make you think that I know what I'm doing. But really, I spent most of my time in the bar, if I'm being honest. So I didn't come away with a great electronics education, and I very quickly started writing software, which was an easy job to get at the time. And yeah, since I'd always been interested in electronics, I took the City and Guilds exam, which is the one you had to do in the UK to get licensed here, about 34 years ago, 35 maybe. It was just something I was interested in, and I didn't really have any contacts in the local club, so I didn't really learn any of the radio stuff, any of the operator bits. I just knew the electronics, and that got me through the exam. But yeah, I still don't know some of the operating stuff. I'm very much a home brewer and tinkerer, and I'm just learning, getting up to speed with the communications aspect of it all. Yeah, so it took me 34 years to make a QSO, and I'm going to talk about the radio that I built and the progress I made to get there. I decided that I was going to make my own homebrew radio and have the first QSO be on my own kit. So yeah. Yeah, and a disclaimer, I'm much more of an engineer and a builder than I am an educator or a techie. I tend to just build stuff. I'm pretty good at making things work. And sometimes the understanding comes further down the line and sometimes not at all. So yeah, back at the end of last year, the last of my children went away to university, and I was left with an empty nest and more space in the house. And I decided to build myself a little lab where I could just tinker with projects. So I began with this QMX, which you can see on the right here, which was the QRP Labs project. When I was a kid, I used to work at a little company soldering all day. So I used to spend my Saturdays just populating PCBs and soldering them. So you know, I've had some experience with that. So I made this little kit. It's very challenging. I don't know if anyone here has built one. It's much easier to get if you get the kit because the waiting list for a made one is something like 6 months at the moment. But if you buy the kit, you can build it yourself. It took quite a while to put together. It's, as I say, complicated, but it worked first time, which I was pleased with. And the first problem I had was that when I connected it to an aerial and tried the transmit tests in the radio, it kept crashing. The hardware would crash. And after a bit of research, it turned out that the problem was that I didn't have a common mode choke on the end of my end-fed half wave, and some of the RF was getting back into the radio. So this is the first thing I made actually in the lab, was this little box. I only have green sparkle, or at the time I only had green sparkle PLA on my 3D printer. But I designed a box in AutoCAD. I looked up the specs for the windings, the coil that I needed to make. I made this thing up, hooked it up to the radio, and that cured the problem. So that was a first success of just messing around really. I also, at the same time, at the back end of 24, contacted my local radio club, and it just so happened that there was a guy there doing Morse classes. I'm really impressed with your club, by the way. So many members. We have like 5 guys there most of the time in York over here, so it's a small operation. But yeah, I started learning Morse, and I'm still learning Morse. I'm just kind of at the point where I can send cleanly and people know what I'm sending, but I'm still struggling with the ear to hear at the rate that I need to. And as I said, when I first did the license, the UK had 2 grades. I think it was like A and B, and you got the B license for passing the exam, but you couldn't get on the HF bands until you'd learned Morse. I don't know how it is in the States, but now it's all changed, and the qualification that I had lets me do anything now. I think it was probably quite a bit harder back then as well. Yeah, so the question was what to make next. This is just a quick picture of the lab that I built. It looks a bit different now. It's actually 2 sides of the room, so the other side looks a bit similar to this, but it's more of an operating thing, and I've put more shelving, and as I've bought parts, there's more sorting out. But this is what I made to enable me to start playing around. And the first challenge I encountered was this one. Quite a few people have heard of this by now. The Solder Smoke guys who have a podcast put out this project. It's a direct conversion receiver made up of 4 boards. There's an oscillator, a mixer, a bandpass filter, and an amplifier. And anyone with a soldering iron and a little bit of knowledge can put this thing together and make a lovely little direct conversion receiver. So this looked like a great challenge, and I put one of these together. I won't dwell on the circuit too much, but this is the 4 stages. I don't know if you can see my mouse cursor actually. But yes, there's the bandpass filter on the top left, the diode ring mixer on the right here with a diplexer, an oscillator, and an amplifier. It's a very simple circuit. The nice thing about it is you can build it in pieces, right? You build one board, you can test it. There's a video tutorial that shows you what you should see. You can use various cheap methods to test it, or you can buy yourself an oscilloscope or a nano VNA and that sort of thing, and do more tests. But at the time I didn't have very much kit, and I built this up, and it did work. It was quite satisfying. And it's a very different thing, right, to homebrew something, to take just copper boards and start soldering components down. It's a much more educational experience. You learn about where things should be placed, how to identify things properly, all the interesting skills. I would really recommend building something that isn't a kit like this. This is the one I built. So this was, you can see that by this point I had some red PLA for my printer, and I was quite keen on printing red things. And this is the board, this is the kit. So this is the oscillator here on the bottom left. You can see I was experimenting a lot, actually. I spent a lot of time playing with it, trying to improve it, just trying various experiments to learn how it worked. So it was a bit of a mess by this point, but yeah, so the oscillator on the left, there's a little power regulator up there. There's a bandpass filter is the next thin board along there. Then the mixer, which is kind of interesting because of the trifilar winding of the coils. It takes a little bit more care to get it right. And the amplifier is the one that everybody falls over with. Usually people manage to get through, if they get through the mixer, the amplifier is the thing that everybody falls over because it's got a lot of gain. It's about 190, 100 dBs or something. And it howls like a banshee the first time you're turning on. You have to decouple the power and mess around in order to get it up to speed. But yeah, so it worked and it was great. And then I started thinking, well, I'll put it in a box. So I learned how to build a box out of PCB material. I was quite pleased with this one, and in some ways, this is the better box that I've built. Maybe because it was an earlier one, and I had a bit more care when I was putting it together. But yeah, this is the same radio, but my version 2, I guess, of the same radio. I didn't mention actually that this radio has a permeability tuned oscillator. So the thing on the far left there is an inductor with a screw that gets screwed through it to change the frequency. And the reason they did this was just so that people didn't have to source and buy expensive variable capacitors. It's much easier to make something with a coil and just a screw that goes through it. Anyway, this is the version I did. You can see the amplifier on the right there. I added some audio filtering as well at that point, I think. But yeah. And then I started getting a bit ambitious at this point. I thought, well, okay, how do I turn this into a transmitter? And I started building this little daughter card for it. Now, the problem you can probably see is that I had made everything so small, and I'd never built a transmitter before. So I put this thing onto a little board. It's a design partially from Llewellyn. I stole various ideas. There's some switching logic, a side tone oscillator here, and a little power transistor, a 3866, and it's supposed to output about 1.5 watts. I think I only got 1 watt out of it, more or less. But yes, it was very cramped. It did work, which I'll show you in the next. So I did actually draw a schematic for it. This is what I came up with, cobbled and stolen from various places. I also learned how to use KiCad so I could draw the damn thing. But yes, there's some switching logic on the left here, which is all about full break-in QSK. There's the oscillator at the top there, which sounded pretty awful, if I'm honest, but it worked. A low-pass filter for the transmitter and the power stage. So this was the circuit that I put together, and my aim was to use this radio to make my first QSO. And there it is, all in the box. It was quite functional actually, but not functional enough. What I wanted to do was test it, so I made this little project. This was the next thing I made, which is a very simple. It's got a Pi. I can't see because I've covered up with videos here. Let me move those here. So it's called a Pirate Pi. It's like if you've seen the Pi Raspberry Pi Picos, they're not so long, but this is even smaller than that. You can see compared to my finger how small this little microprocessor is. And I just paired it with an opto isolator, and I made it into a little Morse beacon so that I could plug it into the radio and have it key the radio with skills that were beyond me at the time, because I hadn't got to the point where I was confident enough to use CW even to send a test signal. And so once I had this, obviously I needed to program the microprocessor. And I didn't write any software, although my day job is writing software. I just went into ChatGPT and I said, give me a script that is a Morse beacon for a Pi Pico, and this is what it produced first time without any modifications. I won't go through the code, but all it does is it sends this message up the top here, which is test from G7LQX / because I was doing a beacon transmission. Yeah, but it just sends Morse by closing that key as if I was keying the radio. Just a shout out to this box parametric project box script. So by this point, I was using a tool called OpenSCAD, where you can write a script that describes the 3D scene you want to build. So it's like CAD software for programmers, if you like. And there's a lovely little script here, where you can say, I want a hole here, and I want 2 pieces, and I want, protrusions, and it makes it really easy to build a box for your projects. So I built a little box, and this has been one of the most useful gadgets I've built so far. It's just got a light on it. You plug the Morse key in one side and USB power in the other, and it just ticks away. And this was, believe it or not, the first test of the transmitter. I literally plugged in the beacon, switched everything on, and after a minute or so, I got a spot in Dresden. My source here is incorrect, actually, because I hadn't filled in my details properly on the page. So I'm actually further north. I'm just below Newcastle upon Tyne here, well, between Leeds and Newcastle upon Tyne in York. But yeah, it was over 1,000 kilometers with less than 1 watt. So it worked really well. But I did discover some problems with it. Oh yes, and this was the guy that spotted me. No surprise that he could probably spot everyone around the world with this kind of setup. He has this kit, and then he has another remote building, and they're all connected together somehow. And anyway, it's worth a look at his website. He's a crazy radio amateur, obviously with unlimited funds. But yes, he managed to reach me. So yeah, what were the problems with the radio? The frequency was variable. There was quite a strong hand effect. The permeability tuned oscillator was a little flaky. Every time I keyed it, it pulled the oscillator more than it should. The power transistor got too hot and I blew one up. The switching logic transistor blew. I think that was just because I was poking it with a meter and I shorted the transistor. The Zener diode that I used as a variable capacitance for the RIT, because I had to pull the frequency for transmit in CW, which I'll mention later. Yeah, that was nonlinear. It was a steep learning curve, and I realized that this thing just didn't transmit reliably on a frequency that I was trying to set in a way that was going to enable me to organize a QSO with somebody else and have success. I did actually briefly try it with somebody, and he couldn't hear me, I couldn't hear him, and it just became very apparent that I hadn't quite engineered this properly yet. It wasn't working in the way that it should. So yeah, one of my favorite TV shows, *Halt and Catch Fire*. I just decided this was the thing that got me to the next thing. So I didn't throw it away. It's beside me actually still. You can see on the video there. That's the back. That's the front. It's just a copper box. And I have used it since for listening. It's a great little radio actually, surprisingly good. But yes, in order to make that first QSO, I needed to take another approach. So I started building a new transceiver, and here it is at an intermediate stage. It wasn't quite finished here, but here it is on the bench, all hooked up and working. And I built it out of separate modules from the beginning, designing it to make sure that everything worked. And I'll just talk a little bit about it as we go along here. Yeah, so it's a QRP CW radio. I wanted 5 watts, not 1. It's a direct conversion receiver. It has full break-in QSK, so when you hit the Morse key, it switches to transmit, and when you release the Morse key, the receiver comes back in. So you can kind of hear the band in the background as you're morsing. It's separate boards, as I said, divide and conquer. I used some ICs this time. The design of the original Solder Smoke radio was all analog, but I decided to let myself use some ICs here for the easy stuff. I wanted a stable oscillator, obviously, without any problems with the keying pulling it, and I wanted a bit more drive. I wanted to add some better CW filters. In the UK on an evening, there's quite a pile up on 40 meters. There's just no way you could make a QSO, especially as a beginner, with all of those signals, especially on a direct conversion receiver with no sideband rejection. And yes, it was for 7 megahertz CW. Originally, I built it for a single sideband as well, so I could do some listening. But I decided against that later on because I wanted more precision in the tuning, which I'll come to. Yeah, so just a brief interlude on how a radio like this works. So often, I'm sure there's a varied range of experience in the audience, but this is often how older radios would have worked. This diagram I generated in an AI today, and it's not the best thing, but it does convey the point that the radio is tuned to this frequency where the white arrow is on the left, bottom left here. And the receiving signal is here. This is what represented by this spike. So essentially the radio is generating the tone difference, the frequency difference between what it's tuned to and where the CW is. So that's how I listen. So the radio is running in that mode and I'm tuned and I'm looking at that frequency that is shown there. But then when you key the Morse key, what happens is the receiver is muted, the frequency is stepped up to that frequency that you can see there, the spike, and the transmitter is enabled and it transmits on the carrier that the other guy is sending. Now modern digital radios just kind of handle this all for you. You can set the offset, but obviously if you're building your own radio and you want to do full QSK, you have to do this. And so the procedure for calling somebody who I have previously arranged a sched with is to tune my radio to the frequency we've agreed on by holding down the spot key. And the spot key effectively switches the oscillator to the transmit frequency as if it was transmitting, but doesn't transmit. So I hold the spot key, I tune to the frequency we've agreed on, and then I can use the RIT control to create a pleasant difference tone, because as soon as I let go of the spot, then I'm about 650 hertz beneath the carrier. I hope that makes sense. Yeah, and if I'm just calling somebody random on the band, it's kind of a similar procedure, but in that case, what you would do is you would hold down the spot key, adjust the tuning until the most that you're hearing, the frequency goes to 0, right? So you try to find that dead spot. And when you found that dead spot, you now know that the transmitter is going to transmit on the same frequency he's sending on. Then you release the spot, you get a nice tone with the RIT, and then with practice you can find that center point. But originally in the old days, nobody had digital oscillators. This is kind of how things used to work, but it takes a little bit more operating practice to get to be able to use a radio like this. So yeah, regarding the RITs, this is an example of it. This is the Hartley oscillator. This is the first module I built on the new radio. You can see a picture here, and this is the circuit. It's got a FET, which forms the oscillator circuit, and then there's a Darlington pair here and an output transformer. But this is the circuit anyway for the oscillator. And this diode down here is reverse biased with a variable voltage, and that's what pulls the transmitter to the right frequency when you hit transmit. That's the spot button. It's called 0 on this diagram. And this is an all designed by W7EL Llewellyn. Yeah, and it gives about 4 volts peak to peak on the output. It's a nice stable oscillator. And that was the first one I built, and that was a good success. So moving away from the PTO, a bit more of a standard design, a bit more solid. Then the transmitter. I actually used the similar design to the one I had previously built, but then I added on an IRF 510 from N6QW. So the first part is, again, this is a Llewellyn design. This transistor here is just for the keying logic, the one at the bottom, but the two at the top there, the driver and the power amp, this gets me to about 1 watt or slightly more. And then the IRF 510 gets me to 5 or 6 watts. In fact, it got me to about 6 watts on the bench, but then when I put it in the box, it got me to 5 watts, and I still don't understand where that watt went to. And it annoyed me for a while, but I realized I could live with it. But yeah, and also the other problem I had with this was I spent quite a long time scratching my head wondering where the power was until I realized that my limiting PSU was cutting in and reducing the current because I had set the current limit too low, which is something I've done more than once since. But yeah, that's the transmit board. You can see the low pass filter in the bottom, these 3 inductors here as well. And I did the same thing, right? I plugged in my beacon because I got to this point, I had an oscillator and a transmitter, so I could try the transmitter. And this is from running it one of the first times. I think the most distant I made here was about 1,700 kilometers into Estonia. And my center point is correct by this point. But yes, you can see roughly where the radio is reaching. But I had a problem. When I looked at the reverse beacon network, which is what I was using to test look at my received signal, I was on 20 meters, which is a bit unfortunate since it's a 40-meter radio. But yeah, somebody had spotted me on 20 meters, and that was because this second harmonic here, the wave in the middle, was only 20 dBs below the primary carrier, so about 50 milliwatts. So I was broadcasting a QRPP signal on 20 meters. Now the license conditions are interesting. They're quite vague depending on where you look. I think this might be ARRL, I'm not sure, but it says the apparatus shall be designed, constructed, maintained, and used only so as to avoid undue interference. But I also found some other references that said maybe 40 dBs below. It seems that in practice, the regulatory bodies are really concerned if you're outside the band and a lot less concerned if you're inside the band. which is probably why these bands are harmonically related, right? So you always end up in an HF, in the wrong HF band, but you're still within the amateur bands. But anyway, this needed solving. So I started looking at how to get rid of that second harmonic. So I learned how to use LT Spice, and I mapped out the circuit for the low pass filter, and I confirmed that indeed, I was 20 dBs below at 2 meters. So at least the simulation matched what I was seeing. And here was my solution. As I said before, I'm more of an engineer than a designer. And I played around. I thought, well, if I resonate out this first inductor, maybe I can put a notch in the transmitted signal. And certainly I managed to do that. I got about 60 dBs, a 60 dB notch in that second harmonic. So yeah, this C2 capacitor here made all the difference. And here is the resulting waveform. This is on my tiny essay. One of the delights of coming back to this hobby is how cheap everything is now, how easy it is to buy test equipment for very little money compared to, when I was a kid and vector network analyzers were silly money, or spectrum analyzers for that matter. But anyway, yes, so you can see I reduced it massively here. I think this is from 20 to 70. It's like at least 50 dBs there. So that solved that problem. Yeah, then the next thing I did was I just tried it with the receiver and the transmitter together. There was no mute at this stage, I don't think. The keying wasn't there, but I could at least plug everything together, switch it on, and listen to the signal coming through the filter on the band filter, and listen to the oscillator forming a radio. So the way I did this was I had previously started boxing up projects. So the things that I'd built before, the radio you saw initially, I took it off that piece of wood and I made a little plastic box for it. So that's the mixer from that previous project. So now I have a mixer that whenever I'm building things, I can just slot it in if I need to try something. That's a double balance mixer. And then the board on the right was from a half-started direct conversion receiver project. It's just a big amplifier basically with a diplexer on it, and which will form part of another radio when I get around to it. So yeah, I just plugged it all together, got everything working, and just tested that I could hear decent signals, and everything seemed clean, and the transmit still worked. And then onto the proper receiver. And obviously, this is one of the places where I wanted to concentrate my efforts. I'd cracked the transmitter. As far as I knew, it was a nice clean tone. But I wanted obviously to build a best-in-class direct conversion receiver. And if you look at the literature, KK7B's, I think he calls it high performance direct conversion receiver, had some of the classic, he wrote a few classic articles on how to design one, and also WSL7EL, and experimental methods as well, had some circuits. So this is the thing that I put together. I'm not sure, did I have yeah, I've got schematics, but they're not finished yet. So I'll just walk through it briefly. You can see the aerial coming in. Actually, that's the oscillator in the top left. And there's a little pad here because I was using an ADE1 mixer, which is sensitive to the drive that you put in with the local oscillator. So you have to pad it a little bit. So I needed to get it down to 7 dB to make it work okay. And then it goes through the same bandpass filter that I'd built on the solder smoke thing. I've had good success with this. It has about a 0.5 dB insertion loss, and that's good enough for me. I get better at winding them every time, but yeah, so that's that. The side tone for the Morse was a 555 timer. I didn't like the stable multivibrator I'd used before. It had a pretty harsh tone. But the nice part of KK7B's design here is that if you put a 555 timer through a low pass filter, you get a lovely sine wave. So it sounds really great. And then KK7B again had a diplexer that he'd designed out and simulated that presented a nice 50 ohms and tried to ground the RF and leave the AF. And that's what this piece here is. And then underneath that, there is a preamp. This is an audio preamp, and then this is a passive 3 kilohertz Butterworth 7th order filter, and then that goes into this dual op amp amplifier stage. for some gain after the direct conversion. So that's the receiver, and it sounds great. It works well. I am stuck in the middle of a city with horrible interference all around me, but that's I can't do much about that. But it does sound well. The only issue I had with this, once I got it working, was I sat on a very pleasant evening listening to it, thinking this sounds great. I'm really pleased. And I went to bed and I got up the next morning and it didn't work. I turned it on and it was just all crackling noise as if something had gone horribly wrong. And I spent an hour, tracing it through, trying to figure out how it had managed to break itself while I slept. And there was nothing wrong with it. I'm just an inexperienced listener. What had happened was we'd had a massive coronal ejection. I'm sure you guys experienced that as well, your side of the pond, but it was, I can't remember what point it was last year when that happened, but yeah, it was space weather basically. There was nothing wrong. It was just that the band was closed spectacularly for a few days due to the coronas. So I just grabbed some schematics. What I've been doing, because I have got a YouTube channel that I've been documenting all this stuff with, is I've been making one big unified circuit diagram of how everything works. But this is, at the time, somebody was asking me while I was building this thing for circuit diagram, so I put some stuff together. And this is just really to show that I steal from wherever I can. So the top left is the solar smoke, the top right is the KK7B diplexer and the preamp, the bottom left is experimental methods, the audio filters, the bottom right is, again, experimental methods. It's a 5532 dual op amp with a really nice clean output for audio. Yeah, so then I went on to the power amp for the speaker. Again, this is from experimental methods. So I actually think I have too much gain in this radio at this point, but not a lot, but too much, I think. Yeah, so this amplifier has another 46 dB of gain. It has a nice roll-off so that it's designed not to amplify the top end, and it feeds a low impedance speaker, and it's quiet as a mouse. It runs really well. Then I got interested in CW filters. I was really paranoid that when I tried to get on there and start, with my poor Morse skills, that I was going to struggle to hear the other end. So this is the first Morse filter I tried. I think it's called the really narrow, but you can Google K4i-CY. It's basically 3 very narrow bandpass filters. It has about a 200 hertz bandwidth, I think. It rings. If you're familiar with that terminology, it's not the most pleasant of filters, but it's actually been quite useful, and it's quite a simple one to build. And you can see it there on the right with me testing it there. And one of the problems I had with this was I realized that component tolerance matters. Because the filters are so narrow, if you don't match all the caps and that determine the frequency or the resistors, then you end up with 3 filters that are slightly apart from each other and you don't get the right effect. So I ended up adding a couple of trimmers. You can see that I use a hybrid of ugly and Manhattan construction. I've been leaning more towards Manhattan, but this was that was what that was. And this is the other filter I saw. This gets a lot of respect online, and it does indeed have a nice signal. And again, with all these pieces, you can look at them on my YouTube channel, and I do demos of all the works in progress. But yes, this is 3 low-pass filters and a high-pass filter, and it's designed carefully so that it's got a noise here. Don't know what that is. Might be my phone. Yeah, sorry. So yes, it's 4 filters designed to maintain the phase, so it's a nice clean filter without ringing. Can anyone else hear the interference your end, or is it just me?
I think it's just
No.
you.
Okay, I'll keep going. Hopefully it'll go away. Yeah, so this is an article I wrote for Sprite magazine a few months back, and then the editor had a nasty accident and spent some time in hospital, unfortunately. So it took a while to come out, but it has just come out last week. And this was a method I had for building cases that I found quite interesting, which is essentially using the OpenSCAD program that I mentioned before to write a script to design a panel, and then you 3D print it, and it lets you play with the layout. You can make a thin slice on your printer, which takes very little time, mount all the components and get a feel for it, look at the user interface, which is something that I'm always concerned with. And once you've got it right, you can even use it as a little bit of as an insulator if you need it. And then I made a copper version and I used it as a template to drill the copper board. So this is a really interesting way of building boards. And if you're familiar with ChatGPT, you don't even have to know how to write the script in the CAD application. You can just say, give me a panel with a square cut out in the middle, screw holes at this distance, make it all modular so I can tweak it, and ChatGPT will just spit out a 3D model for you. So it's a really great way of prototyping boards. Somebody on Facebook asked me, why? Oh, I just draw mine. Well, I think this is a much nicer way of doing it because you can tweak it as much as you want. If you with a drawing you have to rub out and move around, but with this you can print as many versions as you like. So yeah, I used this method to come up with the front panel for this radio, which I called the First Contact appropriately. I'm also quite into science fiction, as I'm sure many people are in this hobby. But yes, so I designed the case this way. I did a plastic printout. At this stage, I was printing the text embossed on top, but I found a better way to do that. So yeah, this was the prototype for the front of the case. And this is how it looked kind of mid-construction. So this is me now moving all of these pieces into a case. And as anyone who's built these things before will tell you, nothing works once you put it back in the case. The beautifully working thing on the bench suddenly has lots of problems when you put it in a box. And I found that for sure. So yeah, this is an early layout. I mean, the boards stayed where they were, but the wiring changed. I was kind of doing a first fix and then I went in and tidied things up. I found also that the oscillator definitely needed shielding. I was hoping I could get away with that, and I just couldn't. I needed to properly shield it. So I ended up moving some things around, and I actually ended up making another board with some switching logic on it to make the entries to the oscillator cleaner. And the picture on the right, that was another attempt at printing the front panel. You can see I was adding like a brushed effect to try and get rid of the lines that the printer created. And again, I didn't finish with that one. But yeah, you can see it was coming along. I was experimenting. Oops, sorry. And here's a look at the final fix internals. You can see I've shielded the oscillator. What I did was I made walls out of copper PCB, and then I used slug tape, the sticky copper tape, just to paste over the top, which is a really effective way of sealing the box and letting me get back in. I think I've cut that tape about 10 times now and gone back in and tweaked things and then put new tape on. And you can see the wiring. I'm not the best at doing all this point-to-point wiring. I need to practice that. I see some designs on the web, but I'm amazed how neat some people are. Yeah, and you can see the extra board here. So there's a little board at the top because I moved some of the keying logic up. I also added a 1 kilohertz filter, which is another Butterworth filter. That's this one above the receiver board. These are the two CW filters, the amplifier, the transmitter. And because I'm building my own kit and I intend to keep building my own kit, I've tried to standardize on 1/4-inch jacks and power pole, an SL239. I've just, from the get-go, I want to make the connections easy and consistent. And there it is. I think it's not the best copper box I've made, but I'm pleased with it. I think I have considered painting it because it did get a little scratched up. And I also tried a magnetic fix for the lid, which didn't work very well, but I wanted to be able to get inside it all the time. So it's not, you can see there's a bit of a gap there, but I'm going to sort that out at some point. But this is basically the radio. You can see at this point, somebody at NVIDIA said, why don't you just print the text on the same layer on the 3D printer? And I was like, no, that's never going to work. I mean, I do have a 2-color printer, but I didn't really think that the printer was capable of that. And I just hit print and it worked first time. I was amazed. So this is a single layer where the printer is choosing white versus black on the print bed and drawing all these tiny little characters. And yeah, the quality is phenomenal. So yeah, it's a little bit sparkly in the picture. It doesn't quite look like that when it's physically there, but yeah, that's the finished radio. Oh, I didn't mention that I also put in this little frequency counter, which turned out to be pretty bad, but I'll get to that. So yes, after all that work, back in December last year, I finally got to the point where I had organized a sched with a friend of mine who had been learning most at the same time. He's actually accelerated a bit ahead of me, mainly because he's using commercial radios and he didn't have to wait to build the thing he was going to transmit on. So he's a bit more experienced than me at this point. But yeah, I hooked it all up. I recorded it in a video and I kind of snipped it up into pieces and showed the best bits. But yes, we made a QSO. I got his call sign. We exchanged signal strengths. We even exchanged FISTS numbers, if you're familiar with FISTS, which is the organization for CW operators that we've both joined. And you can see on the right there, I had a cheat sheet of what he might say, what I might say. So the usual stuff you do, right, when you're trying to make that first CW call. So yeah, it was my friend Neil, M0NJH. He said the tone was really great. I think he was quite surprised how clean it sounded, but I was off frequency. I was about 20 hertz, I think he said, away from where we'd arranged. And there's a reason for that. Mainly the reason is that the frequency counter doesn't let me see that level of accuracy. So I didn't know where I was within 100 hertz. But also the radio has a little bit of a variation, about 10, 20 hertz from where I expect to transmit. I have to find when I use the spot key versus hitting the Morse key, there's about a 10 hertz difference. And it's consistent, but it's there. So, you know, in your head when you're operating, you've got to kind of keep these things in track if you want to hit in a dead set frequency. It's not a problem if I'm calling somebody random back. But yeah, with these modern digital operators with their really narrow filters, you've got to be close, otherwise you fall out of his filter and he can't hear you. He had no problem hearing me at all. He's rural, out in the hills. I had a lot of difficulty with him. You can see on the video, there are points where he goes so quiet that he gets lost in the noise, and then he comes back strong, and then he goes quiet. So yeah, we got there. It was, I'm not going to say it was the best contact ever made, but we did the basics. And I need to practice my Morse. I've been so busy building radios, I haven't spent enough time getting to the point where I can do the CW. So what worked well? There was a clean tone, as he said. The CW was shaped nicely, and the 5-watt transmitter worked really well. The QSK, I'm a real fan of this QSK full break-in. I don't know why you wouldn't have that. And the answer, if you're a home brewer, is it's hard. You've got to time everything. You've got all this extra switching logic. It's just a bit of a pain to set up. The CW filters sounded great. The passive ones are really great. And actually, I think all I need is a passive 1 kilohertz filter. The VFO is stable. It takes 10 minutes to settle. It drifts about 200 hertz, and then after 10 minutes, it's rock solid. It's, moves a few hertz every hour or whatever, which is kind of what Llewellyn said in his original article about that Hartley VFO. That was I get the behavior he expected. It has clean audio and a nice side tone. And of course, the biggest success is I achieved the goal. I learned a lot, a heck of a lot. Yeah, so as I mentioned, the failures here, the frequency counter is not good enough. It only has 100 hertz granularity, so I can't really see to the hertz level where I am. Using RIT and spot is challenging for a beginner. You're trying to make that contact. You're also trying to adjust things and not fall away from him, all that sort of thing. The active filters, they're a mixed bag, actually. I think I've got some level issues. Sometimes the active filters go crazy and very loud, and I hear very clean Morse that's almost painfully loud. And sometimes they just don't seem to extract the signal at all. I think an AGC would help, but then you start adding AGC to a direct conversion receiver, and pretty soon you start to think, well, maybe it should have been a superhead. You can only go so far with these things. But yeah, the best filter is the 1 kilohertz passive. It's the right combination for me. There's some backlash on the tuning knob, which is the word I just heard the other day, which basically means that when you tune the main knob, there's a moment where it doesn't make a difference. There's a mechanical issue where sometimes you will tweak it just a little bit, but the frequency won't change or might even drop a few hertz. And it's just down to the mechanics of the way the vernier and the capacitor set up. I wish I'd picked a cleaner capacitor with a smoother action, and I wish I'd got a better vernier dial, but they were the ones that I had. As I said, it's hard to tune precisely, even if you know the exact frequency, and I do have another frequency counter that I use. It's quite hard to get into the last few hertz of where you're aiming for if you're trying to make a QSO with a known frequency. And I lost single sideband along the way. It's a great radio for listening to single sideband, but for the reason of the tuning issues, I reduced the range in order to make it easier to use. Yeah, as I said before, I think it has too much gain. The preamp and the 4 amps, the CW filters can suddenly be very loud. And also pressing the spot key versus keying the Morse key versus setting the rate to 0 are not quite the same frequency. It would be really nice if they were aligned, and they're about within 20 hertz. I mean, they are consistently different, but they aren't the same thing. And I never really got to the bottom of that. So it might be that there's a minor bit of pulling on the transmitter. There are interesting issues with a potentiometer at 0 that isn't quite at 0. Things like that. There are little issues that aren't really worth worrying about, but I did spend some time trying to figure them out. Yeah, and as I said, AGC would be nice. I have considered going back in and giving myself the single sideband and removing the frequency problems by just putting in a digital VF4, right? If I put an SI5351 in there and a digital display, I'll have the ability to accurately set frequency, and probably, yeah, it'll solve those problems. So I could retrofit that, and that might be a project that I end up doing. Just a brief note on my next thing. Because I'm a software engineer and I'm used to the interface between hardware and software, that's what I do in my day job. There's a natural step here for me to try making a software-defined radio. And so I've come up with this idea of making a black box software-defined radio where it's a very simple portable box with an aerial socket and a USB connector. And all the processing of the signal and the control of the radio is done on your iPhone. So you'll have an iPhone app and you'll be able to tune and even maybe send CW from. But yeah, this is early stages. I actually got some CW out of it last night. This is just the digital bit that you can see in the screenshot. And I've built this test bed, this application, which lets me do an FFT of the signal, lets me profile the Pico and see what's going on. So that's early stages. I've got a couple of videos on YouTube about that, which you can look at if you're interested. Yeah, and I just thought I'd share some of the obvious references. I don't really know what the technical level of the audience is, but I mean, I'm sure the people there that do homebrew stuff will have heard of all of these guys. But Dave Richards builds beautiful radios. I'm quite interested in the aesthetics of things, and I think he's worth a look just because you've never seen circuits hand built like these ones. It must take him forever. I mean, he's concerned himself with the bend on the resistor cable when he solders it in. I mean, those things are perfect. Nick the Vic, M0NTV, he's a UK guy, I think. He does great tutorials in homebrew. He's built a few receivers. Charlie Morris, fantastic. He's very good at building a circuit and then walking you through how he designed it and how it works. He always says in his videos that he's no expert, but don't believe him because he is. Paul Taylor is VK3HN. Now, who is he? Oh, yes, he's the guy from Australia, I think. He builds these amazing portable radios, does his own circuit boards, makes some amazing kit. They are very complex portable radios that he uses for Porter and that sort of thing. Yeah, most people have heard of Pete N6QW. He's one of the Solder Smoke broadcasters, but he's been around forever and been quite influential. He's got a sudden transceiver, which might well be something that I start to build. That's the superhead. It's the next stage from a direct conversion. So that's something that I think probably I should have done before I did the software-defined radio. It would be more useful to get that in the middle first. So I've been considering having a go at that. Hans Summers from QRP Labs, as well as selling those lovely little radios, he does lots of little esoteric homebrew projects. If you go to his website, you can find all these little things. He likes to experiment with, turning a torch into a transmitter or whatever. He's quite interesting. The Solar Smoke guys are great. They do a regular podcast, talk about what they're building. And I've just discovered this new one, Ham Radio Workbench. And again, it's three guys that you might be familiar with, and they just chat about what they're building and what they're doing. Yeah, so that's basically it. This is my website. It's an old screenshot actually, but oh no, this is a new one. I replaced it earlier today. So yeah, you can go and see all of this. And I did actually, as I was building the first contact radio, made about 25, 30 videos of the radio. So when I built the transmitter, I didn't just build it, I stopped, showed you it working, talked about it. So you can go in and listen to me witter on for many hours if you want to. And please feel free to subscribe. I'm on a mission to try and get 500 subscribers. I don't need them, but it's kind of a fun game, playing the YouTube game to try and get more views. It's an interesting thing. Yeah, and that's my email if you want to ask me any questions. I guess we'll have time for questions now. I don't know how long
Yes,
that
we
took
do.
me.
What we'll do is we'll take some questions here in the room, and then Zoom, if you've got questions, can you put them in the chat, and we'll get to those. So let's see if there's anybody. Oh, we've already got a few. Stand by.
I assume everybody could hear me. I kind of rambled and just went for it, but
No, we hear you just fine.
great.
This is Justin AI6YM. In one of your photos of the internals of the transceiver, the mounting block that you had for the power pole connection was a little 3D printed block. I think I recognize it. Can you tell us where you got that design from, or do you have a closer picture of it?
Do I have a closer picture of it? It's from Printables. Can I just email it out? I'll find it for you. I don't know if I've got a close. Well, I can show you it right on the camera. There it is. So it's want it the right way up. So it's just, yeah, as you say, 3D printed. I printed a few of them and they've been great. It's got a little screw that holds the power pole connectors inside, so you kind of slot them in, put the screw in, and then they don't move. And I had a module. I added a module in the OpenSCAD that will always make me the right hole and the screw entry, so I can just drop that onto any panel that I make. But yeah, afterwards I can make a note of that and I'll send you the link. I'll have to find it, but I think I know where I got it from.
I'm laughing because I didn't post that to Printables, but hi, I made that.
Oh, well, there you go. It might not be Printables. I might be lying. It might be one of the other sites. There's a few that I go to. So
yeah, I'd be very curious. But as soon as I saw that picture, I laughed because I don't believe we have any overlap, and I think that's the farthest I've seen my work and travel in the wild.
Oh, great. Well, thanks very much for designing it. It's a very useful little gadget.
Okay, I've got another person here.
Yeah, hello, Chris. I had a friend about 40 years ago, W6RUH, Wayne Ryder, who built everything in little enclosed compartments, circuit boards, like a 6-dimensional cube. Every unit was separated from other units to avoid birdies. Amazing, absolutely. And no birdies in his receiver. But I see your last picture, though. It looks like you did use that technique. That's good.
Yeah, that's right. Yeah, I because the shielding, I wanted the oscillator to be stable, and I found that I could stabilize it by doing that. I also I didn't mention it, but I got some through-hole capacitors, these kind of weird capacitors that have like the cable goes directly through the middle and they mount onto the case, and you can screw either side. So yeah, I tried very hard to isolate things there, but I think in future I would go further and I would use more copper dividers, as you say. I think it's just sensible design practice for sure.
Next question. My name's Dave K6WA. Wanted to find out, you drew up those schematics quite nicely. Apparently that was part of your mission in life to do that as well. So I saw a title block on that and so on. Are you going to distribute those to the four corners of the earth, or what's your plan for that?
Yeah, for sure. For the new project, I'm doing them as I go. I'm being much more sensible about it. But for this one, because I kind of was stealing pieces, it was all in my head really, and I was kind of just soldering up the thing on the day. And that obviously isn't. I wouldn't recommend that approach. It takes a lot more churn to get things right. But yes, I've been drawing a schematic for the first contact. I actually have it right here. Well, no, I don't have the schematic, but I've got the box here. I did bring it down so you could see it in the flesh. But yes, I've drawn the schematic for most of it. I just haven't got there yet. I've been doing a little bit at a time because it's a big thing, and then I have to kind of look in the radio and figure out which components I switched out or changed versus the schematic I stole them from. So there's a little bit extra work for me to make sure that I don't make any mistakes. Now, I wouldn't go read my schematic and build the exact thing because who knows what I'll miss. But yeah, it should be a fairly accurate picture of what the radio is and how it all fits together. What I'll do is, my plan is to finish the schematic, do a video walkthrough on the YouTube channel, and then do a post-mortem at the same time and kind of show off the finished thing and just wrap up the whole project. So that's coming.
Anybody else with questions? Oh, we got one here. Stand by.
Hi, this is Mickey Kilo Oscar 6 Alpha X-ray Zulu. You mentioned that there was some troubleshooting you had to do pretty much at every stage. What debugging tools or testing tools did you have in your bench or your setup to help you figure out what was going on when something didn't work right?
Yeah, can you still see my screen?
We can.
I added an extra slide because I anticipated this question. So there we go. This is not quite what I've got. I haven't got this fluke meter. I'd like it because it's very nice. I've got a much worse multimeter, but everything else is the exact model that I bought. So I have the Tiny SA Ultra, which I think is about probably $100 there. You can probably get it cheaper on AliExpress or whatever. The Nano VNA, which is usually about half the price of the Ultra, which is about $50, something like that. The Rigol DS1102, which I think is 100 megahertz, 2-channel scope, and this Peak LCR meter, which I love for measuring caps and inductors. So this is the test equipment. Yeah. So the Nano VNA for obviously it's great for resonating end-fed half waves and figuring out your SWR, but it's also really great for bandpass filters. You feed them through and it tells you what the bandpass is. A very, very useful device. I've only skimmed the surface of what you can do with that thing. The Tiny SA, as I say, a spectrum analyzer, which is fantastic to have. It's really, really useful. And I couldn't live without the oscilloscope. If you were just building the Solar Smoke project, there have been guys that have done it with very little test equipment. But really, if you're serious about this stuff, this is the kit you need. And, it's not beyond the bounds. It's not silly money. It's $2, $3, $50, $4, maybe $400, something like that for all of that kit. And obviously you can go crazy, but I just bought what I needed. I missed the function generator as well. I bought something reasonably cheap. I do have other ways of generating functions, but yeah. While I'm on,
Perfect.
I've got this PSU, but I actually have my own homebrew PSU, which I use mostly. But current limiting PSU, I would say, is essential. The number of times I've shorted out the power rails and probably could have killed some components without it. As I said, you have to remember that sometimes it'll kick in when you don't expect it, but it's very useful. This is the printer I used, the Bamboo A1. It's the beginner printer of choice. You just plug the damn thing in and press print and it works. It's a phenomenal piece of kit. And I even added these because I think these are fantastic. These are the tweezers that you can use for stripping the enamel off enameled cable for coils. Anyone who's done this will know it's a real pain to get the enamel off the end of the wire, and this is a special tool designed just for that. If you haven't got one of them, run out and buy one immediately. And I quite like the bent nose pliers for holding components while I'm soldering. Yeah, and I did have another slide to say this is the only book you need. That was probably a more thorough answer than you wanted.
Yeah, got a few more questions here. Andy, go ahead.
One more question. Have you looked into the field programmable data array FPGA approach? to building an entire transceiver. We had a talk. I can't remember. Was it here or Fars or maybe both? I have built a beautiful transceiver, all the bands and everything, and using it based on the FPGA.
Yeah, I mean, that sounds fun. That's not out of the bounds of reason for me to do that because of my background. But yes, that's probably a project 3 years down the line. We'll see. I'm on a progressive journey, right? The software-defined radio, I think everybody ends up building one of them because you can go in an early level, really. There's direct conversion receiver, superhet. I'd quite like to build a regen. I'd like to build something with valves, go more old school. But yeah, I've got a progression of projects as everybody does, I'm sure, if there are homebrewers in the room. But yeah, that would be the ultimate, wouldn't it? It would be a fascinating thing to build something like that. Maybe a retirement project, which I'm homing in on as we speak towards having even more free time.
All right, got another question for you here.
Sure.
Thank you. Tony, KM6AM. I'm sort of curious what your, I guess, favorite and or bug you're most proud of squashing is as you're doing this, or I mean, even in your work that you've done as well. Just kind of curious what, maybe not the hardest one, but the one that gave you the most satisfaction.
Interesting. Well, that transmit bug was interesting because I had to learn how to simulate things and experiment. I'm trying to think. There were just so many problems, right? I mean, you sit down and the thing doesn't work, and you end up prodding, and you get to the point where you're like, yes, I blew one of the switching transistors, and that took me quite a while to find, and then I was delighted when I found it, and I took it out and put it back in, and everything just worked again. So there's moments like that. It's like software development, right? Most of us are in it for that little shot of adrenaline you get when you get to that bug that you've been looking at for 2 or 3 days. And I have some real nasties sometimes. But yeah, I can't think of specific examples off the top of my head. As I say, I have an interesting approach to debugging because I'm not a details man. I'm kind of more of an engineer. So I will often just prod things and just see what changes and then kind of home in on an intuitive solution. I'm quite good at guessing. But yeah, I can't think of a specific example. But yeah, maybe the transmitter one was fun to do. And I'm sure there'll be more as I go along.
Well, it sounds like I just saw a text come up, Ben. Is there anybody on Zoom that might have a question? Ooh, let me give you the mic.
Oh, yes. What was the most surprising thing the AI did well to help with your project? Everything. Effectively, ChatGPT is my co-engineer for all of this stuff. It's the first place I go when I'm designing anything from a transistor amplifier to anything. I have a folder in ChatGPT. I have my own account actually, so I can get access to the best models. And I have a project in there which gathers together all my documents and everything conversation that I've had. And it's an ongoing discussion. GPT is phenomenal for electronics. It will lie to you, it will hallucinate, but you hear a lot about that, and my experience is really that if I have a problem, it knows how to solve it, and I just have to ask in the right way. So yeah, I use GPT for everything. The designing the boxes and the panels using the OpenSCAD was really surprising. There was an amazing moment where it hadn't given me the right script, and I had this case that I was designing with some holes and protrusions and things. And it wasn't quite doing what I wanted. It was putting the hole in the wrong place, I think. And I took a screenshot of the 3D model that it had generated, the script file that had generated the model. I took a screenshot of the picture from the 3D CAD tool, and I fed it back to GPT. And I said, no, look, this is what I'm getting. That's not what I want. And GPT said, yes, I see what I'm doing. I'm using that function, and I've got the thing 90 degrees rotated, and it spat out a new script and it fixed it. So, there are moments, that's probably the most surprising thing, that you can actually, there's that round trip is available. AIs are amazing. You just have to know how to speak to them, I think.
Very good. All right, we got to start packing it up or going forward here. Anybody else? Last questions?
Maybe one last question, then we got to wrap up, I think.
Yeah.
Sure.
Wow. So you definitely put the wow in homebrew, I tell you. I've been looking around the room, and there's a lot of programmers and engineers here, and they're like, their eyes are like, wow, this is pretty cool stuff. For me, I'm glad I can go buy my radio. But that says nothing bad about what you've accomplished. It was very interesting. Thank you for showing up. You're welcome to stick around or go back to bed.
Yeah, I think I'll probably go back to bed and try and get some sleep.
Yeah.
This would be a great meeting to attend, but unfortunately our time zones don't match.
Okay.
But anyway,
Yeah,
but thanks very much for listening. I hope it was all was useful to some folks. And yeah, I would encourage everybody to have a go at this. It's
All right.
not hard.
Thank you so much. And
Thanks very much.